Alright, how's it going? So I showed this to my afternoon class yesterday. So Gothard, you know Gothard, right? He was cleaning out the back of a physics area and he came across the Unix system handbook. And this thing is awesome. This was originally 1982, but this printing is from 85. So 30, 40 years old. And I'll just pass that around for your reading pleasure. But it's like, this is all like stuff that's still like valid, right? It's basically what we talked about in 224 and beyond, and it's unchanging for the most part, right? A few tweaks here and there, but you know, shell programming and basic commands and so on, still the same as they were, which is pretty cool. So that goes on my shelf. So any questions before we continue with review?
So is it common for workplaces to use like Linux servers for development, or is there something more common now?
Linux is still pretty popular as a development environment as far as I know. I mean, it really depends where you are. But yeah, it's definitely something you're likely to encounter. Just because it's, you know, it's cheap and it's well understood. My experience has been the larger companies are kind of locked into their ways of thinking. So it's like Windows, you know, and every year one company I would work for, they would have a big committee and they would meet and they would discuss, you know, should we go to Linux this year? And at the end they would say Windows. And the rationale, you know, one of the top 3 reasons was nobody ever got fired for recommending Windows. And it's just true, you know, so it is what it is. But yeah, definitely some of the smaller tech shops, you're probably gonna see Unix. So, which is good.
Have you seen the advertisements for the Windows terminal now?
No.
Yeah, it's a new thing they're working on. They plan on releasing it, I don't know, like this winter or something.
So what does that do?
It's like a terminal, Linux terminal, but made by Windows for Windows. So, you know, Unix systems have already had it for like years and years, but it's open source, so you can download it.
So is it like a client kind of putty thing just for connecting, or is it like a whole little environment?
It's its own like environment, like its own terminal, and then you can just like connect to your servers from there.
Okay.
So it's not like a putty where it has like that user interface, but it's more like the terminal you just open on.
Yeah. Okay. Well, that's cool.
Yeah, it's kind of interesting.
Yeah, definitely worth a look. Probably not going to get me back to Windows. Doesn't hurt to look. I'll take a signature sheet.
Sweet.
Yeah, if anybody else has signature sheets to turn in, go ahead and send those up. Alright, so yeah, your final is on Monday. Technically, this section would be at 10 o'clock and the afternoon would be at 2 o'clock. If you want to come to a different section, that's fine. I don't think it'll be overcrowded, but who knows. And I've written your final, so it's 6 programming questions and then 15 short answer questions, like multiple choice, not short answer. Yeah?
Is this final going to be more like the 224 final or more like the 222 final?
What does that mean?
224, everyone did really badly on.
That's true.
And 222, it was closer to the midterm, you think?
Yeah.
If I had to guess, it would be more like the 222 then. I'm not sure why people would have done worse on the 224 final. I don't know. But the multiple choice question should be very straightforward on this one, and I think that might have tripped some people up on 224. I think I asked a lot of like Unix questions, commands, and things like that. Plus it had regular expressions, which I always like. So I don't anticipate people are going to see any surprises on the final. And the usual 4 pages of notes, double-sided, 2 pages single-sided. No changes there. All right, well, we made it through try catch blocks we talked about yesterday, so we were up to swing and GUIs. So what would I like you to know from here? You don't need to memorize, all that code that Eclipse generates for you. I don't expect you to be able to write that on your own. But if I gave you a chunk of code like what you get from Eclipse when you say create a JFrame and put a button on there, right? I'd like you to know what that code does, right? When there's a button listener, I'd like you to be able to go in there and know that that's the code that gets executed when you press the button and then do something. Okay, so the things that you had to do to make your GUIs, you should be familiar with. Also, using the paint method. Okay, so JPanels, for example, come with the default paint method, which draws the background and the borders and things like that. And we talked about overriding the paint method to do our own graphics, to do our own drawing. So draw a circle, draw a rectangle, fill oval, things like that. So I'd like you to refresh your memories on that, right? And basically, if you make your own panel, you can say class my panel extends JPanel. And if you make a public void paint graphics G, that'll get called whenever that panel needs to be painted. And then you can do any of the things that the graphics class lets you do. So, like I said, draw oval, draw rectangle, things like that, draw a line.
Is that one that we have to call up to super implementation?
That we have to
call up to super?
Yeah, so in the beginning of paint, you almost always want to call super.paint and pass it G, so that it does the initialization that normally happens when paint gets called. Otherwise, you get the sometimes desirable effect where everything that you painted before stays on your widget. And if you want that, you can play around with it. But usually, first thing you do in paint is call super.paint, pass G to it, and then go ahead and do whatever methods from the graphics class you want. There's graphics 2. Graphics 2 has some more features. Some people prefer that. You may also see paint component being used, and I think that's actually the one that most people use instead of paint. Exactly the same concept, right? So another important point on paint is that putting something in paint doesn't actually cause anything to happen until paint gets called. And you can't call paint yourself, but you can call repaint, right? So panel.repaint, and repaint doesn't take any arguments. And it basically asks the manager to call paint when it has a chance. So if you want to do an update on a display, typically what you do is do whatever you have to do so that paint will display what you wanted to display. So if you want to display a picture of a mouse wherever the cursor is, right, find the cursor coordinates, save those in your MyPanel class, right, in some way, shape, or form, and then write the paint method so that it looks at those saved coordinates and draws a picture of a mouse at that location. And then call repaint, right? And repaint will cause paint to be called, and it'll do your drawing. All right, another key concept is that all this stuff is event-driven. Right, so we don't sit in a loop and wait until a button is pressed. We create a listener, usually Eclipse creates a listener for us, and in the code of that listener we write down the code we want to have executed when the button is pressed. And then we go off and we do nothing until the button gets pressed, and then this code gets called and it runs our instructions. So there's mouse listeners, there's button listeners. You can make a listener for when the window gets resized. You can make listeners for when you press a key. And, again, that's all mostly auto-generated for us if we're using Eclipse. But all these listeners basically get fired when some event occurs. And event-driven program is more the norm for what you'll see in like modern systems. A lot of what you do coding-wise will be doing event-driven activity as opposed to just a plain old loop. All right, so threads. We talked mainly about extending the thread class. but you can also make a class that implements runnable, and then you can construct a thread with that. So the only way that I need you to know how to construct a thread is by making a class that extends thread. So you can do something like class T extends thread. And there's somewhere inside this class you need to make a public void run. And that can't take any arguments, otherwise it's got a different signature. And then somewhere else I can say T my thread. And you can construct an object of whatever type of class that is. And you can pass arguments to that if you like in the constructor. And then if you say name of the object dot start, right, you didn't write a start method in here, but you inherited one from thread. And that start method does all the magic to create a new thread, throws this code into the thread, and then calls the run method in that thread, or sets the run method to, sets that thread to call the run method. So now you've got a separate thread executing whatever this code is. And you can share memory between threads, right? If this thread that you construct has access to an object, it can read the value of that object, it can change the value of the object. If you want to make sure that changes made to an object in one thread are visible in another thread, you can add the keyword volatile. So you can make your flag volatile, for example. I think that's about it. Yeah.
So the reason you have to make it volatile is because it changes the way it's stored in memory, right?
Yeah.
Right.
It stops it from being cached locally.
Okay.
So each process, each thread has its own memory space. And rather than go out to sort of the central memory repository, it keeps a local copy of it. And I don't know what the rules are for updating that copy, but if it doesn't get marked as volatile, it doesn't seem to go out and update it when it changes in another thread. So you're basically short-circuiting the caching. Yeah.
So we have two types of linked list. The first one we have to declare the node. The second one we learned before that the linked list contains the rectangle.
Okay.
Yeah. But I did see we declare the node.
For linked list of rectangles?
Right.
Oh,
It's different the regular linked list.
it would be the same code. So you'd have a class list, right? And you'd have a class node. And your data might be a rectangle. And your next might be another node. Right, so that's what your node would look like. And then the mechanics of your list are pretty much the same, right? If you just want to insert in the beginning, see if so you've got like header node. And if you don't have a sentinel, right, you just start your header at null. So insert or add. Right, so if header is null, just set header equal to n. Otherwise, set header next equal to, set n next equal, okay, we'll just do this. right? So if there's nothing in the list, just set the header to our new node and return. Otherwise, and let's say, yeah. Right, otherwise set n next to point to what the header was pointing to, and then set the header to n and return.
But we had discussed this.
Okay. We're actually using a linked list class. Yeah, so you're actually using a linked list. Yeah, so that's not using code that we wrote, right? You're looking at code that uses this built-in linked list. So we did linked list bracket rectangle. Right, so we were, in that example, we were just using the linked list class. And you don't need to define a node for that, right? Your view of a linked list as an abstract data type is just a collection of data. In this case, the data is the rectangle, right? But as an abstract data type, you never really think about the nodes, actually. It's just store my data one after another. And so, you can say something like get and put in an index and treat this thing like an array. You can get the first element by saying get 0, you can get the second by saying get 1, and so on. And that's what that example was doing. Does that make sense?
Yeah.
Okay.
So we don't need to declare the node.
So no, if you're using the linked list class, you don't need to declare a node. Exactly.
So the class array list,
Mm-hmm.
linked list class that stores it like an array.
Yeah, basically. And you know, all of these things are kind of the same. They look pretty much the same to us. And a linked list might actually be implemented as an array list internally, right, or vice versa. And some of these are just interfaces, and you can't actually construct something of that type. But this is a full-blown class. But it's got, you know, basically the same methods. You can get at a particular index, and so on.
So it makes it different from a collection.
So collection is an interface, right? So you can't construct something of type collection, but you can build a class and say implements collection, and then you have to write certain methods, but you also have prototypes for different methods. So collections are what lays underneath, say, a linked list, which is an abstract sequential list, which is an abstract list, which is an abstract collection. All right, so it's that whole hierarchy. All right, how do we get to that from threads? I don't know, but that's okay. So threads, so start method is what you call to start a thread, and once the thread starts, it executes what's in the run method. Okay, if you just call the run method, you're just calling a method, you're not creating a new thread. So you write run, but then you call start to execute it as a new thread. And just, I don't think you need this for the test, but just a mention. Sometimes it's useful when you construct a thread to pass this as an argument. And if I'm inside, class main, then when I pass this, I'm passing an object of type main, right? So I could have something in here like main parent, and my constructor would take an argument of type main, and then I could say parent equals p, and do whatever else I want. And so when I construct the thread, I pass the identity of the thing that constructed it to the constructor, and it saves that in parent. And now inside this thread, I can get back to anything inside this parent class that is available to me by using this object parent that I saved. So if I have variables here, I can say, parent.flag, for example. So it's just a way to foster communication. And of course, this thread over here can get to things in this thread that was created because I know the identity of that. It's called my thread. So I could say my thread dot something and get to fields in here or methods in there. So you can set up communication like that. Or if you make 3 threads, you can tell them each about the other 2 or whatever. And you can go crazy with accessors and mutators as well. So that's sharing data among threads. So synchronized is important. So what is the punchline here is we can make sure that sections of code are only run by one thread, right? So we can say synchronize and give it an argument, which is an object, and that's the flag that it holds up when it wants to run the code. And if that code starts executing, any other thread that tries to execute that same block of code will wait until that first thread finishes. So it's a way to control access to code or objects that are used inside the code.
Does that only work for threads that are of the same class?
No, it works for anything basically.
Okay, so
yeah. See if we can get into trouble really quickly. I'll come back to that. This wouldn't take too long. Write some test code. Right, make your main process, make a thread, synchronize them on some set of code, and convince yourself, inside the code, maybe wait for the person to hit enter or something, and convince yourself that the thread blocks until you do that. Okay, so synchronize lets you control access to shared data. And that ties into things like deadlock and live lock, right? So main thing to know, deadlock, live lock, basically 2 or more processes, threads, waiting on something that each other has, and you cannot move forward, right? So you each need 2 resources, and you each have one of them, and you're stubbornly refusing to give up your resource until you get the other resource, and so you're never going to finish your task. And live lock is very similar to that, except you both release the resources and then allocate them again and end up in the same situation. over and over and over again. So deadlock is two people standing in a doorway and neither one can get past the other because you're standing right in front of each other. And live lock might be you both keep moving side to side over and over and over again, but you still can't get past each other. All right, sockets. So sockets are these sort of virtual endpoints that you can use to communicate between processes across machines, if you like. And the two classes we worked with were socket and server socket. Okay, and socket is typically used on the client side. Server socket is used on the server side, obviously. So server socket you construct with a port number. A plain old socket you typically construct with a port number and a host ID, which can be a name of a machine like Linux, engrcs.com, or it can be an IP address with 4 numbers. So typically you create a server socket and then you call the accept method and that waits for a connection request. So if somebody else somewhere creates a socket and binds it to the address of the machine that the server socket is listening on and the same port number, then the accept call returns a socket which is connected to the socket that tried to make the connection. So now you have 2 sockets connected together and you can write into one, read from the other, and vice versa. And lots of try-catch blocks in there, right? Because trying to bind to a port, trying to create a socket bound to an IP address, trying to read from a socket, write from a socket, these can all throw exceptions. And again, try to keep your exception statements, your try blocks, as small as possible. And so we talked a lot about client-server model. So server, typically something that runs and doesn't exit and just takes in requests and sends back responses. So a time server takes a request, sends back the time. A multiplication server takes in a pair of numbers, sends back their product. A whois server takes in a name and sends you back information about it. So PA5 chat program, right? Your server basically took in a connection request and would just receive messages and display them, but you could also send back. But it's still a client server model. All right, know how to write comments in code. But do you? So what are the 2 ways to write a comment in code?
Log comments by slash.
Yeah, // or /*. You may see a question on that.
Or you give it off to your intern and then have the...
Yeah. There's probably a program somewhere that like comments your code for you. It would be pretty easy to do, but they wouldn't be very good comments. But if someone's just looking for
there
like...
is one that does that, but it just like, it'll calculate how many times the loop runs, and it'll like, this loop runs 10 times. And then,
Right.
This is a print statement.
Mm-hmm.
And stuff like that.
There's programs that generate journal papers that have actually been accepted at conferences. And they say nothing, but they sound, like they were written by someone with a PhD. So, yeah.
So back to comments. Are you going to test this on that block comment? You know how you were explaining?
Oh, no, the Java doc?
Yeah.
No. So I won't ask you about that, but yeah, there's this thing that if you do a /*,
Yeah.
right? That's still just a comment, but the Java doc utility will pick that up and let you put in special things that'll turn into Java documentation. I'm not going to test you on that. So that's pretty much it. So other questions? I'm going to start lecturing on other stuff otherwise. So I think everybody's in really good shape for, not just for the exam, but for moving on beyond 223. So the exam should be pretty straightforward. Monday during the exam, I'll let you know when I'm going to be around next week if you want to come in and look at your exam, or if you have like super late last minute signature sheets you need to turn in or something, but please don't. Try to get them in early. But it'll probably be on that Wednesday, possibly Thursday, but I'll let you know next week. Final count. How many people are going to graduation? Graduation's fun. Yay.
I have a question about that. So,
okay.
Most of us qualify for the AST track degree.
Mm-hmm.
Okay. So my advisor over at WSU was asking me if I qualified for that, because then you cancel off one class in the senior year
okay.
or some. Okay.
So if you're planning to finish at Clark right this year, definitely go into your student portal and run a degree audit. Okay, and that will show you the requirements of the degree, which courses you've applied to, and which courses are still missing. And that's kind of a really good benchmark. And if you've taken PE and it says you don't have PE, don't panic, because their system has a glitch. If you take a 2-credit PE course, it doesn't show up as PE, because the requirement says, you know, department equals PE and credits equal 1. And so if you take 2 credits, it doesn't match. And it's just a glitch in their system. So a human looks at it eventually and fixes that. But yeah, so degree audit is a good idea.
Okay.
Just to kind of see where you stand on their system. But yeah, you should be good for AST2 if we've been doing the plan of study.
I didn't do physics yet. I'm doing that at WSU.
Okay.
So I might not be able to, but eventually, I guess.
Yeah, and I don't know what the actual requirements are for graduation, because the whole AST2 program is way beyond just what you need for the AST.
Oh, okay.
Right, to get junior status at WSU, you take all these extra courses here, and some of those are not required for the AST2. So, like, I don't think they need 3/4 of physics, for example.
Okay.
Which part?
Wait, what?
To get an AST2.
Oh, okay.
I don't.
Yeah, to get an AST2 is I believe 90 credits, right? And you can find worksheets on the website, and you don't need 4/4 of calculus. You don't need 3/4 of physics. You don't need Cse 223, right? But that's just to get an AST2. And with an AST2, if you transfer to WSU, you probably start as a sophomore. Okay, so taking Cse 223 and 4/4 of math and all that sort of stuff, and physics, right? That's part of getting you to start as a junior when you transfer. Yeah, no, physics is good.
I wouldn't go that far.
Well, physics is one of those things that, like,
Physics is good, just not in Clark.
I wish I had done physics more. I wish I had learned more of it, and I've actually sat in some of Gopher's classes and learned a lot, just because it like took 30 years to sink in. Yeah.
You know if you don't accept like physics credits from Clark, because I hear they don't accept 11 credits from this.
The only course I'm aware of that UW does not accept is this one, 223.
Nice.
But I don't know about physics. I just haven't had that come up. Yeah.
I feel like you should tell more people about the summer physics course that you told me about.
Oh, okay.
I'm signed up.
Are you signed up for it?
Yeah.
Oh,
So
cool.
I start in a couple weeks.
Let me know how it goes.
I'm terrified, but I'm not working anymore.
So Summer of Physics is a program at PSU. It's basically their summer offering of physics courses. And it's, I don't know, how long is each one?
3 weeks.
3 weeks. Okay, so it's 3 weeks, 5 days a week, morning to evening of physics. And you end on a Friday, and then the next Monday you start another 3-week session, and that's Physics 2. and then you start another 3-week session, that's Physics 3.
And then when's the funeral?
I'll let you know.
So in one summer, you basically get through all the physics requirements, right? And it's calculus-based physics. So it maps to the physics sequence here.
So they have
Good
like
luck.
multiple, thank you. They have multiple ways that you can set up your schedule. I took the 3 days a week for lab, Monday, Wednesday, Friday. Starts at 8 a.m. and then the class is every day from 11 to 2:15.
Okay.
And you can also take lab 3 days a week in the afternoon, so after class it would be until 5. So
Okay.
you could do morning or evening lab.
Okay.
But
So you got a
every
few
day-
hours to sleep.
Every day the class is from 11 to 2:15.
Yeah, cool.
Just hearing about this, I'm panicking.
I'm panicking too.
This is the dream. You're about to wake up, and it's the first day of summer of physics.
I can jump off of STEM, right?
No. That's why the door is locked. And WSU has told us that physics is very tight up there, right? So
Yeah.
you're already taken care of?
Yeah.
Okay, good. Yeah, so so it's not always guaranteed. If you don't take physics here, it's not guaranteed you can take it when you transfer at WSU. So it's a slippery thing to mess with, but sometimes you gotta. I think summer physics would be cool because it's like immersion, you know.
Oh, it's.
You'll be sweating,
I'll let you
miserable,
know.
and then
Yeah. It saves you from thinking that there's something else besides physics in between, you know. It's like
for a
nonstop.
summer you'll forget that you have a life.
Yeah, yeah,
And you're supposed to breathe.
yeah. Which I think could be
like
cool.
End of day one. Okay, get ready for your tests.
Right, right. Yeah. It's kind of like 270 in the summer that way.
Don't tell me that.
What's that?
270 in summer.
I'm doing it. I'm excited. I have it with Nick, so it's gonna be great.
270 in summer is nice actually because of the lab,
Yeah.
right? Because it's 2 hours lecture, 2 hours lab. And you go straight from the lecture to the lab. And I'm in there and everybody else in the class is in there. And so it's not like, is there somebody around who can help me find a new chip or something like that? It's like, it's part of the class. And I think that works really well. All right. Anything else? I'm going to let you out 10 minutes early today. And tomorrow, I think I'll just talk about some C++, just as kind of another object-oriented thing, not on the test, obviously. But Spring Thing also starts tomorrow at 10, or Friday at 10.
Start using
so.
Endo.
Yeah.
What did WSU mostly focus on as far as
So I've been told there's a lot of Python.
Really?
And I've been told, this is just from students, I've been told that you're kind of expected to know Python from the beginning. Like they don't necessarily spend the time, certainly don't spend the course teaching Python. But Python, if you know Java and you know C, is pretty straightforward. It's got a few weird things, like you have to indent your code, right? Instead of using curly brackets, you indent your code. That's how you mark off the blocks. Yeah, which if you don't know is really weird, but once you know, it's actually kind of cool.
Because everyone uses the same format.
Yeah,
so
yeah. So there's definitely Python, but definitely a lot of C also. So like 360, which is some programming, is all C as far as I know.
Okay.
And they'll get into sockets and they just start looking at things like that. And I'm not sure they do a lot of Java.
See, I had heard in the past that they do a lot of Java because, but this was years ago. that
Yeah,
my
I had heard that
brother went there.
from other students, and I just haven't heard much about it lately, so I'm not really sure. You can definitely check the syllabi, because a lot of their syllabi are online now.
Yeah.
Oh, they are?